Hi, my name is John. I'm going to be going over some quadratic functions with you today. Quadratic means a degree of 2. We know that the degree of 2 is located right here. It has an exponent with the highest power of 2. So let me rewrite this really nice and big for you. Function of x is x squared minus 8x plus 5. So we know that this is the quadratic portion right over here. It's a degree of 2. It says write the following quadratic function in standard form. I had to look this up, what they mean by standard form. Most books call this the Vertex form. I have no idea what they call it, this standard form. The Vertex form looks something like this. Y equals a parentheses x minus h squared plus k. That's called the Vertex form. In your book, it's going to be called the standard form. A parentheses x minus h squared plus k, and your vertex is h comma k. And we notice that when we talk about degree of 2, which is quadratic, we know that this is going to be your vertex right over here. Okay. So it says we write the following quadratic in standard form of this function right over here. We have to complete the square on this one, so it's a little bit difficult. Okay. First thing we're going to do is we're going to rewrite it. The function looks something like this. It's x squared minus 8x plus something. So I'm going to factor out this 5 right there. Plus 5. See how I put plus 5? And then minus something. And I always like to write this in so that it gives you an opportunity. So if you add the same amount, you must subtract the same amount. What we do is now we look at the linear term, which is the 1 right there. So it's negative 8 divided by 2, excuse me, and then we square it. So we always take this number, the linear term, divided by 2, and we square it. That becomes negative 8 divided by 2 is negative 4 squared is going to be equal to 16. So we're going to add 16 and we're going to subtract 16. And that makes perfect sense because you're adding the same amount and subtracting the same amount. The equation has not changed. So the function looks something like this now. We are going to have to factor this. I'll show you an easy way to factor it. So the square root of x squared is x. Drop the minus. If it's a plus, drop the plus. So it's a minus right there. And you take this number, divided by 2, it's going to be minus 4 squared. If you forward this out, it will become x squared minus 8x plus 16. And of course, 5 minus 16 is minus 11. So we have it. We have this in vertex form now, just like this. Our a value is 1. Our h value is 4. That's our h. And that's our k. So the vertex, write the following vertex form, we just did that. That's all we need to do. Okay. Example number 2, here's a function. Here's what it looks like. F of x is equal to negative x squared minus 4x plus 2 this time. It's a little bit more tricky because of this negative right here. Write the following quadratic function in standard form or vertex form, same thing. First thing we'll do is factor out a negative. You got to factor out that negative or whatever the leading coefficient is from your function. It's going to be x squared and it's going to be plus 4x. That's a little tricky because if I distribute the negative, it becomes minus 4x plus something. We're going to have to complete the square using the same technique that we did here. It's plus 2 and minus, now, since this is negative 1 times something. And I'll look into this a little bit later to look at the intuition of why that happens. Okay, just a little bit later on. Well, let's complete the square on this one. We take 4 divided by 2 and we square it. 4 divided by 2 is 2, square it, that becomes 4. I'm going to add 4. It seems like we're adding 4, but we're actually subtracting 4. So right over here, I'm going to put in orange, 4 over here, 4 over here. let's look at the intuition. Since we're subtracting 4, we have to, minus and negative is positive, we are going to add 4. So don't forget to write this down so that you know that you have to subtract this leading coefficient times 4. So we complete the square on this one. F of x is equal to negative. We drop it straight down without the square. Drop the plus straight down. 4 divided by 2 is 2 squared. And then we have to evaluate this one. Well, of course, plus 2 plus 4 is plus 6. So let's write the following quadratic function in standard form. We did that and we're good to go. Again, let's reiterate this one more time. It's going to be minus 4, so we have to add 4. Okay, and I like to put this information ahead of time so we don't forget. It's going to be a minus negative 1 times 4. Write the following quadratic function in standard form again. It's going to be a little bit more difficult because of this minus 3. So let's rewrite the function. F of x is equal to negative 3 x squared plus 18x minus 1. Like I said, that negative 3 is going to kill you. Not that bad though, hopefully. Factor out to negative 3. If you factor out negative 3, it becomes x squared. Factor out negative 3. If you think about this, it should be a minus 6x. If I distribute that, I get plus 18x. So it takes a little bit of thinking, but not too much, okay? Plus something again, and then minus 1, and then minus negative 3 times something, okay? So we have to figure out what completing that square is. We take negative 6 divided by 2, which is negative 3, and then we square it, which becomes 9. So we add 9. Inside, we add 9 here. So do I have enough space? I have just a little bit enough space. That becomes negative 3. Let's factor that out. Square root of x squared, just drop the x, minus half of 6 is 3 squared. If you distribute that out, of course, it'll become that x squared minus 6x plus 9, the trinomial. We have to evaluate this. It's going to be negative 1. Minus and minus is plus 27. Negative 1 plus 27 is plus 26. And so there it is. I hope you can see that. Negative 3 parentheses x minus 3 20 squared plus 26. Okay, next one. Example number 4. Given the quadratic function, state the vertex of this function. This is already in vertex form, or what they call standard form. The standard form, so we're trying to find the vertex. Okay, the function looks something like this. Negative 11 x minus 1 squared plus 10. And the vertex form, or the standard form, the way they have it, is equal to a times x minus h squared plus k, where your vertex is going to be h comma k. So that's my h inside there, and that's my k. So my vertex, I don't even have to worry about the negative 11. It's going to be 1. It's the opposite of the inside. Okay, guys? You guys have to remember that. It's the opposite of that negative, which is positive. The outside stays the same, and 10. Your vertex is equal to 1 comma 10. If you're not quite sure why that works because of negative, if you plug it in here, that's your h, right? Plug in 1 right there, it becomes this part. Your k plus 10, that's your k value right there, plus 10, and there it is right there. So that should give you a little bit of intuition why on the inside it's the opposite, the outside is the same. Okay. Example number 5. Given the following quadratic function, state the vertex. Well, this is pretty easy. That's your h, that's your k. Your vertex is h comma k. That's what we're looking for. Question mark. It's going to be the opposite of the inside, which is negative 9. and k stays the same, which is 7. It's a coordinate. Don't forget, that's the coordinate of the vertex. One more note on example number 4. Since your vertex is at 1, 10, there it is. Since this leading coefficient, that's a negative right there, that's your a value. It's negative, it's going to go down. Something like this. Okay. Example number 5, it's negative 9, 7. So it's going to go negative 9 here, and then up 7. And it's going to be positive, so your parabola is going to face up. The smiley face. Okay, I hope you can see that. Because this is positive right there, it's going to go up with a positive smile. If A is negative, it's going to be a frown. Sorry. We don't like negatives, so that's a good way to memorize it. Okay. Example 6. For the following quadratic function, find the vertex. Well, right now, at this stage, most books call this the standard form, but I don't even know what they call it in their book. General form, maybe. So let's say, for instance, this is the general form for the function. To find the vertex, there's another way to find the vertex without completing the square on this one, because it might be a little bit difficult. So we're going to find another way to find the vertex. Your vertex, that's what we're looking for, of your x-coordinate is negative b over 2a. This is a little bit difficult to memorize, so I'm going to show you a little trick that I use to figure out how to find that. The quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. Everybody remembers this formula, right? Or most of you anyways. It's this portion right over here. It's the negative b over 2a. And there it is. That's your a, that's your b, that's your c. So it's negative b, which is negative 4 over 2 times a, which is 2. So your x-coordinate is going to be negative 4 over 4, which is negative 1. And we have to figure out what your y-coordinate is. So again, this is your negative 1, your x-coordinate of your vertex. What we do now is we plug into this function f of negative 1, and you should know how to do that by now. Plug in 2 times negative 1 squared plus 4 times negative 1 minus 1. Negative 1 squared, PEMDAS as squared first, 1 times 2 is 2, minus 4, negative 2 minus 1 is negative 3, with a negative. And I'm going to use a graphing calculator to show you how that kind of works. Let me bring out my calculator first. You should know how to graph these by hand too on your calculator, so it shouldn't be too difficult. First, what we do is we go y equals, let's clear that one, 2x, you can see a little bit better, 2x squared plus 4, here's your x button, minus 1. And press enter, that kind of sets it. Check your window, negative 10 to 10, negative 10 to 10. We're just going to graph it. And your vertex seems to be at negative 1, negative 1, negative 3. Oh, there it is.